Hi, I'm Dr. John Apsley. Along with David Yurth, I'm here to help moderate and also present over this wonderful weekend. And I would like to also thank George for helping this university to set up such a wonderful conference. My background is that the legal team that is representing some of the sailors on the USS Ronald Reagan contacted me and asked me to help organize and coordinate a medical team to do an evaluation of the sailors and to institute treatment for what was consistent with radiation poisoning. So this weekend for me is also a fundraising opportunity, and we have two nonprofit organizations that are able to receive small donations that are complete tax write-offs, and I'll be presenting that information a little bit later. What I'd like to do right now is to go right into my first PowerPoint presentation. And a lot of this Dr. Klein went over, so you'll see some of the same pictures, and I'll have probably about the same comments on them as we move forward. So that'd be great. Thanks. Thank you, Nick. Okay, so again, this in review, this is the plan that it looked like Fukushima Daiichi prior to the earthquake. And if you'll notice, that wall, that tsunami protection wall that's built in front, as Dr. Klein indicated, was only designed to handle about a 20-foot tsunami wave. And as Dr. Klein indicated, the tsunami that came in actually was closer to 50 foot. So it was unable to shield the plant from this huge volume of water that came in at great speed. Go ahead, Nick. Next one. Again, from the right to the left, you have Unit 1, 2, 3, and 4. Those towers that you see in the back that are shared for the exhaust are part of the design of normal operations allow radioactive materials in gas form to pass up through those towers. One of them is radioactive hydrogen that I'll be talking about a little bit later. What I do want to show is that on the far left, you see Unit 4 there. Behind Unit 4 is another building. It's called the Common Fuel Storage Area. And that area has a huge amount of stored spent fuel that, of course, is a lot cooler, but it also has a great deal of radioactivity still in it. And as Dr. Klein showed, the Japanese were very fortunate that when the tsunami hit and Units 1 and 3 exploded, the current wind at that time was headed to the northwest. If it had been heading due south, it would have hit Tokyo with full blast, and the story would have been completely different. Go ahead, Nick, next one. Again, this is a similar picture to what Dr. Klein showed. This wave just kept on rolling through, and as we already know, it wiped out close to 20,000 people. Nick, next one. That's I remember actually observing that on TV in real time. It was terrible to see it. Next one. Now you can begin to see the size of this wave. This is also the Day1 plant as the water's just starting to come in. And this is the water coming in. This is the initial stages of the water coming in. And soon overwhelms the entire plant. Now, my understanding of what happened might not be quite as thorough as Dr. Klein's, but let me go over a little bit of a review. Unit 1 is to the right. As Dr. Klein indicated, when the hydrogen blast took place, it blew out the panels of the roof. And the resulting explosion was subsupersonic. It projected maybe 1.5 miles to 2 miles up into the air, releasing among about 30 different radioactive isotopes, a lot of cesium and iodine. Unit number 2 suffered basically a meltdown, a rupture in the torus, which was at the bottom of the facility underground, where a lot of the water cooling mechanisms just simply overheated. So although the roof didn't explode on Unit 2, because you can see it there, it's intact, the bottom had ruptured, and this is what caused essentially a meltdown at unit number 2. Unit number 3 was a supersonic explosion. It went twice as far into the air as Chernobyl did, about 5 kilometers. In this particular facility was nuclear fuel that was more enriched with plutonium than the other facilities, and hot particles of plutonium were found up to 2 miles away on Japanese soil. And we actually had some readings here of plutonium that were captured in some air filtrations. Plutonium is an interesting element because it helps the nuclear fuel to burn hot or be more efficient, but it also is thought to be about 20 times more lethal to human beings because of the kind of radiation that it emits. The alpha particles, if they're inhaled, sooner or later they will cause cancer, and this is what our concern is with the sailors on the USS Ronald Reagan. In that flotilla, those ships were mostly standing off of South Korea at the time of March 11th, 2011, and they were ordered in for search and rescue operations, and U.S. Ronald Reagan at first sailed in within 5 miles of the facility, according to sailor testimony. Unfortunately, that wasn't part of the original Admiral's report, but at 5 miles out from shore, that plutonium that was coming off of the explosion off of Unit 3 was likely impacting some of the actual snow and precipitation that was coming down over the USS Ronald Reagan. There's 5,000 sailors on board, but other ships that were in the area going with USS Ronald Reagan made the total amount of military of our people there closer to 20,000. So within this 5-mile range, there was an astounding amount of radiation that was being breathed in by the sailors. And then as soon as all the alarms and klaxons went off for the radiation, because they are fully equipped to detect radiation on board these ships, the entire flotilla was moved about 80 kilometers offshore. Unfortunately, the plumes were still coming to the northwest, exactly where the ships were. And so the technicians on board the ships were measuring radiation constantly. And we have information that the amount of radiation that was hitting the ship was absolutely astronomical. We actually have the real numbers, and it's mind-boggling. What we do know is that 20,000 sailors were likely exposed to highly injurious levels of radiation. What we also know is that helicopter crews were flying into these plumes on a regular basis for days. I spoke to one of the maintenance crew members who both flew on the helicopter as well as tried to wash it after the fact, and their badges that detect radiation were simply off the chart. The equipment eventually was decontaminated in Bremerton, which is not too far from where I live in Seattle. And most of that equipment could not be cleaned because there is a tendency of these particles to grab onto metal and just stick, and you can't clean it despite all attempts. That was discovered during the above-ground nuclear testing in the Pacific back in the early 50s, and most of those ships just simply had to be scuttled. So we're a little bit concerned with the USS Ronald Reagan due to the amount of radiation that it took. Now, as Dr. Klein indicated, the unit that still concerns me the most right now is Unit Number 4. Unit Number 4 was shut down. The nuclear reactor was shut down, but its storage fuel pool was holding an enormous amount of spent fuel rods from the other facilities. Okay. So now to the bottom of the screen and slightly to the left, we see the common storage fuel pool that has approximately 6,500 assemblies. We have 1,550 assemblies stored in Unit Number 4 and a smaller number in the other storage fuel pools that were also damaged in the other units. Okay, go ahead, Nick. It's just a back view of it. Now, where you go back to that. Yeah, if you were standing right here looking down, there'd be a hill, a very tall hill here. Part of the problem when General Electric built the plant, they built it, as Dr. Klein indicated, it had some difficulties with how it was constructed and the amount of seawall that should have been built and so on and so forth. But the real problem is that there is a large hill that's right where, as if we were standing on it here, looking down on the facility. That hill has an enormous amount of groundwater that is just by Mother Nature is designed to go right into the ocean from here. Well, the problem is that that huge amount of groundwater is going right through the plant. And during the what's called the liquefaction process of an earthquake, where the ground is turned into basically liquid, there is a tendency of that groundwater to find all kinds of new channels to make its way through gravity on down to the Pacific Ocean. So these facilities now being damaged have been suffering leaks in the bottom where the corium, the spent nuclear fuel that has melted through, not completely the entire containment, so it's not a China syndrome where, meaning that all of the radioactive fuel has melted through the containment itself into just raw ground. It has remained, according to everything known, within the containment building, but at the very, very bottom. It has melted out of the reactor. And unfortunately now it looks like the groundwater has been able to penetrate into those basements and is making contact with that corium, and that part of the cleanup operation is not well under control right now. So it's just flowing into the Pacific Ocean. Okay, next one. This is a comparison between what Fukushima looked like after the various accidents on the left and Chernobyl. Chernobyl did not have nearly the number of safety operations that was present in the GE-built facility on the left. When helicopter crews flew over the Chernobyl facility to dump huge amounts of concrete that contained radioactive absorbing materials like boron, they created a sarcophagus, which still exists today, and they saved probably Kiev. At the time when the air currents were going, they were also going to the northwest. Kiev was due south, and as luck would have it, most of the radiation went into Belarus. The eastern half of Belarus is still heavily contaminated. There's all kinds of biological impact ongoing and will be ongoing for several hundred years at least. And Kiev was spared. And by the time the helicopters had been able to put a sarcophagus around Chernobyl, when the wind currents changed, again, just a lot of the fallout had stopped. What I like to say is that those helicopter crew were not by a remote control. We had helicopters that were under remote control that were able to fly over unit number 4 on the far left side there, that building that you can see is damaged, and the amount of radiation that was measured was 4 sieverts. That was a combination of between 1, 2, 3, and 4, but 4 sieverts is lethal. Well, the helicopter pilots who flew over Chernobyl to dump the materials to create the sarcophagus all died within a very short time period from the radiation, mostly gamma. Gamma radiation just penetrates through almost everything. Okay, next one. And here is what I was saying. There's Kiev down to the south. Chernobyl is right dead center, and then the wind currents took most of it into the northwest. The southwest part of Russia was affected. And as you can see, about half of Belarus is been totally devastated and will be so for hundreds of years. We do have a survivor of that time period. She's going to be speaking later on tomorrow, who saw people in her family and her neighbors just die very quickly and or over a number of years. She had no other place to live, and so they had to harvest the food that was there. They had to harvest the mushrooms. They had to harvest the produce, the only food sources that they had. And when she eventually wound up in the United States is when she really got sick. I'll let her tell her story, but it's a fascinating story how she recovered. And we also know how people recovered from the atomic bomb blasts on Japan during World War II, and that led to the science of how people that are exposed and have absorbed radioactive particles can actually be recovered. And that's my work with the sailors. Okay, next one. Again, this is the facility after the fact, and I actually labeled the common spent fuel storage facility. Okay, next slide. This is the amount of nuclear fuel that was present in all the different units, and also in Day1. Go back that just for a second. So Dr. Klein said that off stage that the operator at Day1 was very, very quick on his feet and also highly skilled, and he was able, through making sure that an enormous amount of wiring was set up very, very quickly, he saved the day at Fukushima Day1. But you can see there was quite a bit of stored radioactive fuel there. What I want to draw the attention to is the common fuel pool, that 6,375 assemblies. Each assembly weighs about 1/3 of a ton. That mathematics that it's there, 110 tons, is not quite correct, but it should be closer to a little over 1,100 tons there. We're talking about a dramatic increase over what happened at Chernobyl. The amount of nuclear fuel that's leaked into the Pacific Ocean has now been confirmed at 3 times that of what got into the water supplies at Chernobyl. And we're still trying to deal with the actual measurements of what radiation was put into the atmosphere. Mathematical models are based upon projections of what's called the source term, where you take a look at the fuel and you ask a series of mathematical questions to predict how much release actually occurred. Unfortunately, mathematical models have never been accurate. They've never predicted the exact amount that actually does get released. So it'll probably be another few years before actual measurements that we can do after the fact will confirm how much release was put into the atmosphere. I can tell you this. One of our cancer patients who had colorectal cancer and prostate cancer was responding to our treatment just prior to the Fukushima incident. And then after the Fukushima incident, he stopped responding. On a hunch, I took soil samples from his property because he raised organic foods. He had organic chickens, organic meat, organic fruits and vegetables. I took a soil sample and sent it off to Boston to a very, very highly qualified laboratory. And it turned out that on his property was 11,000 picocuries in the soil, which is an astronomical amount of radiation. So that had come over from Fukushima. It had cesium-134 in it, and, in addition to cesium-137. So the West Coast got hit. Turned out that I just happened to be the one, it's just a total coincidence, of collecting the soil sample that was by far the highest in the nation on the West Coast. The second reading that was detected was a little over 3,000 picocuries of radiation in the soil around a dairy herd in California. And that same area was the one that the National Geological Survey also found to be the hardest hit. We'll see a map on that in a second. Go ahead. Next one.
Could you also speak up just a little bit more?
Yes, I will speak up a little bit more. Thank you. Okay, so what we see here is the nuclear reactor in the middle. That red vessel is where the chain reaction takes place to generate the heat that then flows out into boiling water, generating steam that drives turbines. At the very top, we see the cap. And at Chernobyl, that cap blew off. And that explosion is unprecedented because now the core was 100% exposed to the upper atmosphere. That did not happen at units 1, 2, or 3, where the explosions took place. The torus, which is that round structure down at the very bottom, is what ruptured at unit number 2, actually leaking radioactive into the basement of the building. But what did happen is that there's a seam that the cap is hooked onto the vessel itself. It's that seam that allowed, when meltdown did occur, when the core, the fuel inside the vessel got overheated, that steam, that like a pressure cooker, the air started escaping rapidly from the seams, and that's where the corium, that's where the hydrogen was produced that created the explosion. What I want to say is that the Nuclear Regulatory Commission, with Lawrence Livermore and one other experimental facility in the U.S., conducted experiments back in the 80s to see what would happen to the amount of cesium in these fuel rods. As Dr. Klein indicated, they're about an inch and a half long. These are called pellets. They're made out of very high-grade uranium. And when uranium starts breaking down, he showed you a great slide of that. It produces these neutrons, and the neutrons start a chain reaction, and eventually this produces a huge amount of heat. But there's daughter products of the uranium, and one of them is called cesium that I'm very concerned about. Cesium is produced in two forms, 134 and 137, and it will basically replace potassium in the body. From the new chemistry of cell physiology, put together by both Raymond Damadian, MD, PhD from Harvard, and perhaps the greatest biophysicist of our day, he's the Tesla of cell physiology, Gilbert N. Ling. We now know that a lot of what we thought about governed cell physiology is completely erroneous. For example, they have proven over 40 years that there is no such thing as a sodium-potassium pump, which is the basis for how we develop drugs in the world. So if something else is governing the transportation of things in and out of cells, we need to know about it. And the core mineral that is responsible for moving in and out, mixing with a particular kind of negatively charged protein, is potassium. That makes a huge amount of things work inside the cell of our bodies. Well, cesium will readily replace potassium more or less permanently because its affinity to grab onto things is stronger than that of potassium. So therefore, cesium now is found present in every, radioactive cesium is now found present in every human being on the planet and will be that way for their entire lives. Any additional radioactive cesium is a real problem in my book. It is the ignition process toward eventual cancer. So now we have these experiments that were conducted by two facilities to see how much cesium is released over what time frame and under meltdown conditions. Meltdown conditions are to at least 1,500 degrees Fahrenheit. And at about 1,500 degrees Fahrenheit, there's a self-ignition system that kicks in where that fuel cannot be turned off to fully combust until the fuel is exhausted or there's no more oxygen present. Well, the meltdown temperatures that happened at units 1, 2, and 3 were in excess of they approached nearly 5,000 degrees Fahrenheit at some point in time. It's known that at somewhere between 1,500 degrees Fahrenheit and 2,000 degrees Fahrenheit, that 100% of the cesium will be released within 1 hour. And certainly these plants, when units 1, 2, and 3, were sustained for maybe as long as 7 hours under full meltdown conditions, meaning the temperature is up as high as they could possibly go. So that in my book, 100% of the cesium came out of the nuclear fuel into the vapor. The question became, where did that vapor go? If it was coming out of the seams of the cap and there was a supersonic explosion in unit number 3, then a vast amount of cesium had to escape that has not yet been fully accounted for. Now, in the initial simulations, they minimized these numbers down after not minimizing them. There were communications in the NRC that we have on a Freedom of Information Act that indicates that the numbers were astronomically high because they had done some projections based upon the total amount of fuel that went into what they thought at that time was meltdown. Within about 7 days to 2 weeks, those numbers started coming back down again due to mathematical models. And as I indicated, there has yet to be a nuclear event where the mathematical models were accurate. So I believe that the cesium that was released into the atmosphere was much, much higher than what anyone at this point has been able to determine for sure. I do know that just like with the equipment on the USS Ronald Reagan, once radioactive particles hit metal, they tend to stick to it really tightly, and it's difficult to get off. So there is a physicist that was the former head of the Nuclear Regulatory Agency in Japan, who's now retired, who said that it looks like that a lot of the cesium was able to combine itself with a lot of the materials in these buildings and just remain in that area. Well, we'll see, because cesium stays as a vapor at those temperatures long enough that it could have escaped along with the explosions. So when the hydrogen explosion took place, that was sub-supersonic at Unit 1 and supersonic at Unit number 3, the question we have to ask ourselves is, with the cesium being in the aerosol state as a pure gas, how much of it went out to the northwest? And certainly the sailors, I'm sure, had been hit with a huge amount of not only the iodine but the cesium. Here, in the mind of the general public, as it happened during this time, is that everyone is running for iodine. Take iodine. Because if you take enough iodine, then the radioactive iodine that's produced, and it becomes a pure gas very quickly, will tend not to enter or stay very long in the body because you already are full of good iodine in your system. Well, what about the other 30 different radioactive elements that taking the iodine doesn't do any protection for you at all? What about those? Cesium is at the top of my list there. Okay, next slide. These are just to go over some of the other aspects of the containment building, which is in green. The vessel itself is in red, and then you have storage fuel pools that in this case you can see to the left. Now this would be a China syndrome, and again, we don't believe at this point that this has happened. We believe that the corium, which is that ugly looking red splattering there, has definitely gone down to the bottom of the facility, out of the reactor vessel, but we think it's been contained there. What we do know, though, that's almost just as bad is that from robots that have gone in, we do know that this groundwater that I was making reference to earlier, it has gotten in somehow to these basements through cracks or whatever, and is making contact with that corium, and then is exiting in ways that we don't fully understand right now, likely going right into the Pacific Ocean. We do know from actual measurements, as I previously stated, that the amount of cesium that's hit the ocean has now been ramped up at least 3 times more than what took place at Chernobyl. Okay, next one. Now this is unit number 4. Immediately after the blast, you can see that the building is in rough shape, and it's actually tilting. Now this was denied by some of the experts there, but just taking actual photos and then doing a proper forensic analysis of the building is leaning over quite a bit. Let's go to next slide. Now this is unit 4. Pretty quickly thereafter, you can see the lines here drawn by an architect where the building is starting to, like the Leaning Tower of Pisa, is starting to tilt over. This is of great concern. The storage fuel pool is in the white box area. And contrary to what Dr. Klein says, I've talked to several experts on this, and what we think happened was, because the cooling system failed at the Unit 4 pool, to the best of our knowledge, although there was not leaks, so I agree with Dr. Klein here, there was not a leak in the fuel pool, at least on the underside, that the heat assemblies became great enough that there was evaporation. Probably at least a third of the assemblies were exposed. Now, there's going to be debate on that for quite some time, but we do believe that those assemblies were likely damaged. There were a series of fires that took place over days in that pool. There were a series of at least 2 explosions, if not 3. So we believe that although the pool itself remained intact, and thank goodness for that, that those 1,550 assemblies, probably a great deal of them on the outer casings, to them that make the assemblies hold up to 68 rods, fuel rods, have been damaged. And like a pack of cigarettes, as you go to pull those cigarettes up to put them into a better constructed storage vessel, which is what's being done now, you'll see it in a few moments, we believe that there is likely to be some of those assemblies damaged and maybe even slightly fractured. So we're hoping that, because this technology has never ever been tried before, it's never been tested before, what TEPCO is currently doing, it's going to be a miracle in my mind that they have no further incidents with taking each one of these assemblies up. The swimming pool is very, very high, it's very full, so they can still take each assembly up without removing it from the water, and then with a crane transport it into a more safe container. And then they take that container, holds a series of assemblies, and they remove that out of the building. We'll see that in just a second. We'll say next one. This is the cocoon building that they built over Unit 4. It's complete. It was complete. Started operational to be operational last December, maybe end of November. And they have these 1,550 assemblies to remove. They estimated it when they started it would take about 18 months to complete. Dr. Klein indicated they may actually be ahead of schedule. They've removed over 400 so far. And it's a brilliant concept. They're going to keep everything underwater, so gravity won't play as big a role as it would as if it had to be taken out into air. And it's just now a matter of whether or not that the structure around each assembly is strong enough to be lifted out and moved. Okay, next slide. This is what an assembly looks like. And you can see at the very bottom these little round areas where these assemblies go into. We're going to see the actual damaged assembly storage fuel pool here in a moment. So we'll also show this picture too. But basically, it holds a lot of fuel rods. And let's go back there. What's important about this is that the distance between each fuel rod, it has distance. If they get closer to each other, then you start forming the basics of a chain reaction. And if it tilts or if it moves or if it's bent, this could cause a criticality fire if some further accident happens. So let's go to the next slide now. This is what the storage fuel pool number 4 looked like pretty quickly after they could get back in there and start taking robotic pictures. You can see there's quite a bit of debris that's hit the bottom of these assemblies that sit underneath this. So the assemblies now are like in a cigarette pack. They're underneath this, and this debris is sitting on top of it. Okay, next slide. This is a better picture. It's more clear. Okay. Now, this is interesting because in January of 2013, a little over a year ago, we were still taking recordings of huge spikes in radiation that were hitting the island. That's quite impressive. Where was that radiation coming from? Now, we know from studies that we've done with our network that it contains cesium-134, so that had to be from Fukushima. It's like a signature element that would come from Fukushima at this time. There are variables with counts per minute with Geiger counters that can cause us to look at different reasons why we would be seeing these spikes.
Check your there you go.
There you go. Thank you.
We're still experiencing a little bit of static at times from that.
Okay, can you hear me okay now?
Yeah.
These CPMs were of enough concern that about a year and a half ago, a volunteer network of 3,000 individuals started taking measurements of radiation across the United States. And as I indicated, we already had data from the National Geological Survey, also from EPA data, as well as from data from UC Berkeley, and then from data, a small number of samples that I took, that the west coast of the United States got hit by quite a bit of fallout from Fukushima. And there are several problems with that. That the initial stories that were told is that by the time that the radiation hits the United States, it becomes extremely dilute. But studies have actually shown that if you take a given amount of radiation and you know exactly how much cancer that's going to cause, eventually that radiation, even if it's dispersed over great distances and diluted, will eventually cause the same number of cancers. That's through epidemiological studies by Stephen Wing at the University of North Carolina. And that's how they proved at 3 Mile Island that the people in the surrounding area that were coming down with cancer left and right were actually poisoned by 3 Mile Island, because initially no one could believe that small amounts of radiation, the so-called small amounts of radiation, could be causing all these health defects in so many people around 3 Mile Island. That lawsuit didn't settle until 1995, and it settled out of part of the public record that we understood just how much damage was done by a relatively, well, compared to Fukushima, 3 Mile Island doesn't hardly even compare. But its lethal effects and its harmful effects do. So we're starting to see these same things occurring to the degree that we can calculate from counts per minute the average amount of REM that a human being would be suffering from. On some of these more advanced digital Geiger counters, they actually can convert instantly to millirem or microrem. And this is an area that I'm very concerned with, because we now have a better understanding about how radiation does damage. Most people think of radiation causing genetic damage and causing cancer. But at low levels of radiation, there is what's called both a bystander effect, which is becoming very well known in oncology circles because of people receiving radiation therapy. And it's uncanny because a higher amount of radiation given therapeutically will actually cause less damage to healthy tissue than a lesser amount of radiation will. That doesn't fit the linear threshold models of the more that injury from radiation states that the more you get, the worse you suffer. That's exactly the opposite. Well, another physicist discovered the same. Commission.
Okay. You dropped it out still. Farrell, could we halt just a second?
Sure.
Let's dig out one of those other cables, the last one going to him, if you can find one. We've got some in there. I don't know where they're at. Wait just a second.
Okay.
Just momentarily. Yeah. Get one of those and just take the last segment to him and substitute one of those. Please, sir. Yeah. Just like that. Something that'll reach him. And take that one out. Substitute. Twisted. Yeah. That one has a connection problem.
Okay, see.
Okay. Check it. Double
There it
check
is.
There it is. Is that better now?
Yes, I think so.
Oh, good. Okay, so let's do the next slide.
Okay.
Let's do the next slide after this. Okay. So this is what I'm worried about. I'm worried about what's called the Pekau effect. Pekau effect was discovered, as I said, in 1970 by a physicist working for the Canadian Atomic Energy Commission, if you will. And he discovered that low levels of radiation were 100 billion times more lethal to cells than higher levels, much higher levels of radiation were. And through subsequent analysis, and this is published at least a half a dozen times, what he found was absolutely fascinating. He didn't find that there was genetic damage that was caused. He found that the free radicals, the hydrogen peroxide, if you will, that was produced inside these cells when they were exposed to low levels of radiation, because that's basically what radiation does in the body. It creates hydrogen peroxide that burns us, or one of the kissing cousins of hydrogen peroxide, like oxygen radical. That at higher levels, he found that those radicals would combine with each other to make water. Well, water's harmless. But at lower levels, they tended not to bump into each other much, so they stayed as a free radical for a much, much longer time period and melted the lipoids, the fats, that compartmentalize our cells into efficient machines. So if you have one part of the cell that does one function, another part of the genes, and another part of the cell that makes the energy, it's wrapped with a fatty wrapper, a membrane. And it's like a hot knife going through butter when these very, very low levels of radiation hit those fat molecules. It just melts it, and the whole cell then can't function any longer, and it dies very rapidly. Well, now you add to it what's known about the bystander effects, that when a cell is damaged or killed from radiation, it itself secretes poisons that we don't fully understand yet that will migrate around to healthy cells that are not exposed to that radiation and instantly kill those cells as well. And to take it a little bit further with the complication, there are substances from the cell that was killed that are also secreted that will help to repair other damaged cells. It's very complicated. So, as you can see right here, this is what happens when there is a 5-kilometer into the atmosphere event of radioactivity containing things like cesium-134, iodine-131, cesium-137, and others. It just spreads continually around the hemisphere until something causes it to fall down. And the physics of that is that we still have plutonium that's floating around in the upper atmosphere from the above-ground explosions that we put off in the Pacific. And every so often it lands. Now, this is what we call accumulation. That since this radioactive debris is going to be active to cause ionization in the tissues for hundreds of years, if not thousands, it doesn't matter if the plutonium went up into the air in 1950, that as soon as it lands here, it's adding to what we just got in from Fukushima, or adding to if we live within a certain number of miles from an operational nuclear power plant. Because law allows an operational nuclear power plant to emit a certain amount of radiation that up until recently was thought to be harmless. But what scientists failed to tell us is that the National Academy of Sciences has published in their BEER 7 report, Biological Effects of Ionizing Radiation, BEER short, that there is no such thing as a safe level of radiation. It's all dangerous. And this is the subject of my talk, especially later on today. This is what we have to understand. We have to get it through our heads that these tiny amounts of radioactivity getting inside human beings are not stopped by our self-protection systems unless we really know what we're doing. So when an event occurs and people start handing out iodine, it's like handing out a Band-Aid when your leg's been cut off. You go after that amount of radiation in a very specific way to protect yourself. And then we need not fear these kinds of events. We need to prevent them, but at least we'll be operating on a stage where that the officials will start advising us properly as to here's the things that you can do, rather than saying things, don't worry about it, when they have no proof at all that, oh, don't worry about it, is true, because it's not true. Just ask people who compose the National Academy of Sciences. Post 9/11, we were very concerned about the vulnerability of our nuclear reactors to airplanes flying into them, as Dr. Klein talked about. A private company went to the Bush administration and said, hey, listen, would you please help us? We believe that with our first responders who might be walking into a dirty bomb situation, that we could protect them. Would you give us a little bit of grant money and we'll design a very simple program that anyone can do that they can carry with them if they find out, yeah, there's radiation involved. This company spent 8 years doing the studies. They did human studies. And they showed that simple, inexpensive vitamin supplements and minerals will indeed absolutely lower the risks across the board of all kinds of radiation that could be encountered in a dirty bomb situation. No one's done anything with that. Thank goodness. I have a large network of people that kept sending me this information. They said, hey, did you see these studies that were done by this private company because they wanted to help the first responders? It was beautiful research. A simple amino acid, vitamin C, vitamin B complex, mineral selenium, and I add in there a little bit of melatonin. Wonderful. Offers all of the ability to cancel out that hydrogen peroxide production while you get focused in on trying to take those particles out of the body. Another thing that people are confused about, we're not talking about the equivalent of a dental x-ray. Why? A dental x-ray is on and off in a millisecond. When you ingest or inhale these particles that are radioactive, it's like an ever-ready battery. It never goes off. It just keeps on going and going and going, producing hydrogen peroxide in your tissues. So when you hear comparisons of dilution factors, don't worry about is coming in low levels. Remember PET cap effects. Remember what I'm telling you here now. And remember that when someone says, oh, don't worry about it, it's like getting a chest x-ray. It's not. A chest x-ray is on and off. These particles that get in our body stay there until we specifically take them out. Sometimes our body on its own is able to remove some of them. But if we give it known help, like this company studied, we can accomplish a great deal. Okay, next slide. Now, this is the ocean current carrying the radioactive cesium and other particles our way. And we know for absolute fact that the ocean's food chain will concentrate this diluted radiation 300-fold back up the food chain. And guess what? We sit at the food chain, top. So every time that some of this gets into the seaweed, and every time the algae or seaweed is eaten by a little critter, and every time a little fish eats that little critter, and then that fish eats a lot of those little critters, it's bioaccumulating a lot of radiation in its little tiny body because it keeps on eating the same critter that has eaten a little bit of it from the seaweed. Seaweed's fantastic at grabbing onto radiation. It's fantastic. So now you have a bigger fish that eats those smaller fish, and it keeps on eating a lot of those smaller fishes. Now you begin to get into biomagnification, where there is lots and lots of radiation building up in that bigger fish, and then that bigger fish is eaten by bigger fish, and then suddenly we human beings catch it, and then we eat those fish repeatedly. And we do not have efficient systems that remove those radioactive particles from our body. This is the problem. Okay, next slide. Now, these are the current sites of the nuclear power plants. Those circles are about 50 miles in diameter around them. And what I want you to see is that other than the one at in northern Florida, can everyone see the one in northern Florida? Not the Panhandle, but around where Disney is. That's one of the plants that's just recently been decommissioned. We know from studies conclusively by taking actual measurements that once a nuclear power plant is shut down, that the rate of certain diseases goes down. And that's been published in the peer review. So what are we going to do about these effects? And I think that just by alerting the public as to some simple things that they can do that will help to protect them from these particles, as well as to help them to eliminate these particles, we would see a lot less of these disease effects that we're actually seeing that are being denied. They're there, they're ongoing. I'll give you one quick example. In 1950, the United States was the healthiest developed nation in the world. All of our chronic degenerative diseases were going down in number. As soon as the above-ground nuclear experiments started in 1952, that reversed, and that reversed hard. Then when the nuclear above-ground testing stopped in about 1962, the naturally reflecting that. They started going down again. When the first nuclear power plants were turned on again in the early 70s, we saw that the trend start up again. Now, another thing that is not given full attention to, that came this private company that petitioned the George Bush administration to be able to help our first responders if they should encounter a dirty bomb, radioactive dirty bomb, was that they noticed that no matter what the other toxic element that we would be exposed to through our food supply or through our water or through our air, small amounts of radiation amplifies that toxicity up to tenfold. Their data show between 8 and 12. So the carcinogen then became, if it was a chemical, unrelated to radiation. With a little bit of radiation now added into the mix, that chemical becomes an order of magnitude more toxic to the human body. And it makes sense, because now you got more free radicals to deal with. So, at any rate, I believe that that by a proper educational program, we should be eating more fruits and vegetables anyway. We should be making sure that our dairy herds aren't located within 10 to 15 miles of a nuclear power plant, because they bioaccumulate in their milk supply a great deal of these particles. Okay, next slide. All right, so anyway, we'll leave the lecture off here. I'll take a few questions, but I've overstepped my time period, so I don't want to take up too much more time. But you can go and see some of the latest information on what's happening with unit number 4 on my website here. And I'll have to update it now because Dr. Klein's educated me very nicely about the current status that's going on there. So thank you for that, Dr. Klein. And I'll see you then later on this afternoon. Are there any questions? Yes, sir.
Yes. So you said that out of all of, you were saying that cesium is the big problem. I've always thought that plutonium was kind of more dangerous. From a health standpoint, what makes cesium more dangerous than plutonium?
So I have a newsletter that covers this. Remember I mentioned that there's a new science of cell physiology, and it was discovered and put down into peer review for 4 decades by this group led by Raymond Damadian. Raymond Damadian invented the first MRI, and he hired a brilliant biophysicist by the name of Gilbert Ling. And what Gilbert Ling showed is that the real mechanism that's driving life, let me explain it this way. We were in med school, we were taught the wrong chemistry. We were taught biochemistry and organic chemistry and organic chemistry. But that's not how the cells actually work. The cells work on a basis that they are a colloid. They work on suspensions of things inside the cell, and because of the tininess of them, they shake. And that shaking is what drives the energy for most reactions, including the DNA reactions, the epigenetics, the genetics, the genomics, and the enzymology, the enzyme systems. Enzyme systems at body temperature work 1 billion times faster than if that reaction didn't have the enzyme to keep itself going. So enzymes are critical. Enzymes aren't something dissolved into water or to the cell's water. They are suspensions. And so he found that, Gilbert Ling found that what normally we thought required a transport system to bring things in and out of cells, that's called the sodium-potassium pump or versions of it, it doesn't exist. It doesn't exist. And fortunately, universities around the nation are just now starting to teach this new biology. So what is happening? Well, the main driver for us is a proline-rich peptide that we get from mother's breast milk when we're first born. And it can be recycled basically for the rest of our lives inside our systems. But we fortunately can get it from whey, high-quality cow's whey, which is identical to human breast milk protein. Not the casein, in cow's milk. That's foreign. But the whey in cow's milk, okay? Well, that's rich in this negatively charged protein, and as soon as the potassium ion starts floating across the bloodstream, that magnetic attraction pulls it right in. Doesn't require any ATP. For the sodium-potassium pump to work, it would require 3 times the amount of energy to make it work than can possibly be held inside the cell. And yet, Chen was awarded half the prize in Nobel Prize in Chemistry in 1997 because the Nobel Prize Committee missed 4 key pieces of research, and they shouldn't have missed it. So we've gone off into left field now as to what's really driving the development of drugs in this country. Okay? And if we understand how nutrients then actually interface with these proteins inside the cell, then we can control a lot more of what rolls out to be the gene play or the enzymatic play. But the last thing to this is that once that potassium hooks onto that negatively charged protein, it causes an oscillation, association induction. It drives massive amounts of biochemistry to make the cell alive. Cesium can easily replace that potassium. That cesium is much more powerful an absorber onto that negative charge of that same protein. It displaces the potassium, and then it sits there in that groove, causes a wobbling that's not normal, because it's not exactly potassium. Remember the wobbling back and forth that drives the reactions? Okay? And it's emitting hydrogen peroxide signals all the time until it completely decays and it's inert. And that can take 300 years. The cesium's half-life is 30 years, but its biological impact keeps on going out over 300. Okay? Depending on the size of the particle. Okay? So this is a problem. And this is the reason why we're seeing cancer rates as high as they are, and why we'll continue to see cancer rates climbing, is because underneath it all, both normal background radiation and now man-made radiation keeps on coming into our environment, and our system isn't tweaked enough to be able to neutralize these radioactive particles coming into the body, in my opinion. Okay. Well, we do know, for example, in these sailors, we have sailors that were cleaning up the mess at Bremerton, Washington, from the USS Ronald Reagan, that were exposed to radiation. And then they left that job, and then 6 months later, they conceive a child. And that child now has congenital defects, genetic disorders. So we have a lot of learning under, because this might take 40 more years of study to confirm, but it's a. Did the sailor have damage done to his future spermatozoa that when he eventually did conceive, that wound up being the cause of the birth defect in his child? Probably. There was a geneticist who was supposed to. He studied all this that came out of Chernobyl, and the data on Chernobyl is astounding. That what the real data is on the real epidemiology of what happened to those folks over there. We were only reported in Wikipedia pre-Fukushima that 31 people died as a result of the Chernobyl incident. It was nearly 1 million that were killed. There were 8 million that were crippled, many of these with severe defects. So these kinds of questions, this geneticist, who's brilliant, has been asking, but they haven't been able to prove it one way or another yet. So, yeah.
Yes. So it seems like you're addressing a lot of complexity. When there are lawsuits and discussions, it seems like it's, trying to make a complicated, sophisticated argument be very challenging compared to, I'm not saying poly causes there's no issue. There is an issue. It seems like small stress. So how would you address that? You are a physician.
Yes. Well, let's talk. let's talk about stress for a moment. Stress is a non-medical disease. It's not considered a disease. But stress is where mind and body have dysregulation. And eventually it translates itself into some sort of chemistry that injures us. And one of the ways that that happens is through deprivation of oxygen. For example, if you're going through a divorce and you get all uptight about it in your shoulders, you're squeezing your muscles so tight that the oxygen flow, the blood flow, is not getting there. And you can have all kinds of headaches from that and jaw pain from that. And if you have too much constriction, your heart can even not get enough blood to it and you can have a heart attack. So it's a matter of lack of oxygen, or when you have a lack of oxygen, you also produce more free radicals, so you age. If you looked at President Obama when he went into office, he didn't have any gray hair, and now he's gotten all gray hair. It's a stressful job. Yes, Sheila.
Yes, sir. This is also for Dr. Klein here. The whole purpose of this conference is to bring awareness of what's coming at us.
Yes.
Our health tsunami.
Yes.
Is being pointed
Now,
out by
repeat
what's
the question after.
Yeah.
My concern is that when this was happening, when we were trying to get the data based upon the jet stream flow
Yeah.
of where those particulates were being carried, my understanding was that the U.S. servers to provide that type of observation were turned off, and we were having to observe it from European sources to be tracking the jet stream that was directly the first area to get it, Alaska and up there. And in 2011, it was somewhat of a blessing for Texas to be in a state of drought because that jet stream stayed way north, and that was the first time I was somewhat happy not to have rain because several weeks later, iodine-131 and cesium-137 was documented in the milk in Philadelphia, water and milk in Vermont and Philadelphia after they had snow. My big complaint is to sit there and watch the EPA levels of safety miraculously get raised, just like that.
Yeah. Well, let me. So what?
My question is,
Yeah.
what type of influence does the NRC or this group have over our government entities to give us good crisis communication?
Well, let me take this burden off your shoulders here, Dr. Klein. We have to thoroughly understand the nature of nuclear power. It tends to scare the bejesus out of the public, and for scientists that can study it carefully and get a sense of what it's really all about, I think there's a sense of security there that if you're a reformed nuclear engineer, you realize that maybe that sense of security wasn't always 100% right on the money. Maybe we don't know some things. But for the most part, scientists really do have a handle on how things should be operating in a nuclear power plant. But we see accidents occur when accidents shouldn't occur. So to answer your question more specifically, we have different influences of our government that are influenced not only by our legislators but also by industry. And we have a problem today that there is a bending of science. There's a bending of science. So if you're a big, powerful industry and you have a lot of money, you can hire the best scientists, but you want them to study a particular way, so there's influence going on there. And it's a problem. This is a widespread problem that's been noted by a lot of litigating attorneys, that when they bring in experts, that they are able to bend science with real legitimate published studies, and still it's bent. There are cases where if you carried on experiments for 3 months with test animals, there's no damage that's shown, but you carry on that same experiment for 9 months and suddenly tumors start popping out everywhere. That's a real example. We know that with gene-modified organisms, right? So we have this problem today that the money tends to, we have the best politicians that money can buy is often one of those statements that's made. We have people that are totally honest in our government, but are they in the right positions? I don't know the answers to that. I can tell you this, though, and this is just how I look at it. The EPA monitoring stations along the west coast of the United States, and this was confirmed by UC Berkeley, was registering a normal background radiation on their graphs, normal printout, on March 11th, those graphs went down by what looks to me like an order of magnitude and continued on like this on March 11th after the Fukushima earthquake. That's in my book. I printed out those graphs. Okay? Now, during that time period when spikes did occur, they went fuzzy. The spikes would show, and then certain parts of it was deleted, and then it would show up again, and then certain parts was deleted. Like, where did that spike go? Nobody knows. Okay. That's in my book. Now, I then checked the company that the EPA was using to take those monitors, keep them operating. Turns out it was a former defense, one of the officials in our Defense Department. She started this company. She was hired by the EPA to do this. And they stated on their website that they were proudly stating, and this could mean nothing. This could mean nothing. She was proudly stating that they had the ability of all these monitoring stations across the U.S. to simply push a button to recalibrate all the measuring stations. That's on their website. I captured it. Okay? That may mean nothing. Okay? But I can tell you this, that as time goes on, like the National Geological Survey, they're recording much higher numbers than the EPA did. Last thing, this is the beautiful thing about what Dr. Klein helped to maintain, if not institute. Every nuclear power plant in the nation that's operational, by law, has to have a monitoring station on its rooftops. We have that data. And that data, from what I've seen, shows that the radiation levels were much higher. But now back to your point. It depends on if rainstorms are coming in at the same time that the radiation is going over our head. You made reference to Philadelphia. Philadelphia's spike in infant death mortality rates over the Center for Disease Control data spiked by up to 45% higher than the previous 3 months. Now, it takes 3 years for all that data to come in, and we're just about there right now to be updated. But so far, this fits exactly patterns that we've seen before. That when a rainstorm hits an area during times that, in theory, the fallout from Fukushima would have been over it, that both the infant death rate goes up from acute infections because the thyroid's hit, and your immune system can't work without a good functioning thyroid gland. So normal flu, normal colds, bacterial, viral, cause much more damage to the infants because their immune system's not fully developed yet. Okay, the thyroid is the thing that is the trigger to that. And also to the people that are immune compromised, the elderly, those rates also spiked. Not just in Philadelphia, in Vancouver, Canada, in Seattle, Washington, all the way down the West Coast, there was an average of 35% increase in infant death rate than was normal, than was expected. Now, you can't say cause and effect there because there could have been some variable that we don't know about. But it's interesting that the only variable that's known was what was blowing over our heads at that time from Fukushima. Okay? So does that answer your question?
I'd like a little more confirmation that all the entities that have influence over the monitoring for the safety of our nation not ignore the warning that Japan tried to give us about a 60-foot tsunami could never happen.
Yeah.
And it's these people, like, they're here today.
Yeah.
Praise God they're here.
Yes.
To get more this transparency and disclosure.
Yeah.
We can solve problems.
Well, George and I had a conversation about this, and I think and forgive me because I'm not trying to be disparaging about what you just said, but and I think you'll agree with me. We sometimes think that the government ought to be the ones to do things like to protect us or to help do all these things that we think of. We are the government. We're the government. We, the people, are the government. If we allow a pocket of bureaucrats who don't fully appreciate the Pekau effect or the bystander effect to cause legislation to occur, then we're responsible for that. We're guilty, not them. It's our responsibility. This website that's monitoring with high sophisticated Geiger counters, 3,000 different sites around the U.S., is brilliant. People are standing up. They're not politicians. No one's paying them to do this. They're all hooked up with software. They're reporting daily, 3,000 different stations. What a wonderful idea. Now, they have to get it down a little bit more scientific. They have great Geiger counters, but they have to do it reproducibly, 10 minutes, same spot. They have to be in the same range of detection of radioactive particles. But that'll come. So it's we the people that are the government here. We shouldn't expect the government to always know the best things for us. Okay, that's my opinion. Okay, next question. Okay, last question.
We actually have. You already asked one. Yeah, she has one over there.
One more. I'm sorry. Go ahead. Yeah.
My understanding, Washington State, like we're talking about radiation things going on over there. I just heard or read an article where children are now being born without brains.
Yes, that's in Yakima.
There's a thing that looking at the picture of growing food in skyscrapers, and when you're talking about cesium or some of these particles attaching themselves to metal, and I think of the industry that we now have, and in trying to create safe places here in the United States, we have to look at where are we getting our materials.
That's right.
And how it's being
That's right. Yeah. So you can. The question was excellent. The question was, with all this radiation that we're now experiencing from different sources, where are the safest places to grow our food? How do we know that our food's not going to be contaminated with these tiny amounts of radiation? And one other step, where are the safest places in America to live that don't have constant exposure from radiation? I'm just putting together a newsletter on that. And they're right here in Austin and to the central south, down to the Mexican border, is a very safe area, with the exception of what's happening over at Carlsbad, New Mexico right now. That's leaking plutonium, and the levels are 5 times greater than what is generally known. We have confirmation that the amount is very, very injurious. And with those wind streams have to be coming over here. In Austin, I took CPM readings from the local volunteers here. It was at 273 counts per minute. And I'm going to go over that in my next lecture later on this afternoon, so I won't bore you with it right now. But it may be a relative number. CPMs can vary from Geiger counter to Geiger counter. But if it's equivalent to the measurements that the National Academy of Sciences used to base how much radiation the average human being in America gets each year, again, making that assumption that the measurements were identical, then the amount that is hitting Austin right now are of great concern. But again, that's an assumption. I'm going to go over that this afternoon. So if you'll be present with us this afternoon, I can really get into some details there, okay? All right, I think we're kind of at the end of my part, so thank you for putting up with me.